In this video, we will talk about how to write recursive formulas for sequences. So I have 3 examples for us to work through here. Let's check out the first one. Let's say we have the following sequence of values. How can we write a recursive formula to explain how to get the next value in this sequence? Well, when we're writing a recursive formula, there's 2 pieces of information that we have to include. The first is A1, which stands for the very first value in the sequence. So we have to specify what that value is. So up here, if we want, we can write a sub 1 is equal to this first value here, this 4. This next value would be a sub 2. This next value is a sub 3, a sub 4, a sub 5, and on and on and on. So the first piece of information that we have to specify when writing a recursive formula is what is the first value? Well, we can see that's a 4. So we're just going to write a sub 1 is equal to 4. The next piece of information that we need to know is a sub n. And this is going to be a rule of how can we get the nth value in the sequence. So if we look at our sequence up here, let's ask ourselves, to go from 4 to 10, what do we have to do? Well, we have to add 6. Okay, what about to go from 10 to 16? Well, we have to add 6 again. To go from 16 to 22, we have to add 6. So we can see each time to get the next value in the sequence, we just need to add 6. So what we can write as our rule is, if we want to find the nth term in the sequence, all we need to know is the n minus 1 term, or in other words, the term right before n, and just add 6. And that's it. This is our entire recursive formula that explains how to find the next value in the sequence. And one thing we'd like to do is usually specify that this rule only applies for n greater than or equal to 2. So because we already know what a sub 1 is, that's 4. So this rule just explains, okay, how do we get all the other values after the first value? So we can see that, for example, if we wanted to use this rule to find the a sub 6th term, all we have to do is plug in a 6 for n right here. So if we do that, we would get 6 minus 1. So that says take a sub 5, which is this 28 right here, and add 6. So 28 plus 6, that would be 34. So that's just kind of a way to double check that, oh yeah, we must have written the correct formula. Okay, let's try another example. Let's say we have this sequence of values, 3, 6, 12, 24, 48. How can we write a recursive formula to describe this sequence? Well, remember the first step is we want to write what is the first value, so a sub 1. Well, we can see that would be this 3 right here. So we'll say 3. So if we imagine this is a sub 1, and this is a sub 2, a sub 3, a sub 4, a sub 5. Next piece of information that we need, remember, is a sub n. So we want to explain how can you get the nth value in this sequence. Well, to do that, we have to identify what's the rule for getting the next value. So to go from 3 to 6, you might say, okay, well, we add 3. Well, what about to go from 6 to 12? Well, we add 6. So clearly we can see this is not an arithmetic sequence. In other words, we're not adding the same value each time to get the next value in the sequence. So another thing we can try is maybe this is a geometric sequence. In other words, we're multiplying or we're dividing by some value to get the next element in the sequence. So instead of adding 3, we could say, well, to go from 3 to 6, we have to multiply by 2. That would work. 3 times 2 is 6. To go from 6 to 12, it looks like, yeah, we also multiply by 2. To go from 12 to 24, we multiply by 2. And to go from 24 to 48, we multiply by 2. So it looks like the rule for getting the next value is we actually are multiplying by 2. So what we can write is, to find the nth value, we just need to know the n minus 1 value, so the value right before n, and multiply that by 2. And we'll say this applies for all values of n greater than or equal to 2. Because remember, a sub 1 we already know is 3. So this rule only applies for n greater than or equal to 2. So for example, if we wanted to use this rule to find a sub 6, the next value in the sequence, we would just plug in a 6 for n right here. So 6 minus 1, that's 5. So a sub 5, that's 48, times 2 would be 96. So we can see that this must be the correct formula, because to go from 48 to 96, we do multiply by 2. All right, let's try one more example. Let's say we have the following sequence of values. How can we write a recursive formula to describe this sequence? Well, remember the first piece of information we want to write is a sub 1, which is just the first value in the sequence. We can see that's 19 right here. So we'll write a 19. So this first value is a sub 1. The second value is a sub 2, then a sub 3, and a sub 4. Now remember, the other piece of information that we want to include in our formula is a sub n. So how can we get the nth value in this sequence? Well, remember the rule that we use. We have to try to find what is the rule to go from one value to the next value. Well, to go from 19 to 11, we could subtract 8. To go from 11 to 3, it looks like we could also subtract 8. And to go from 3 to negative 5, we could also subtract 8. So it looks like our rule is to get the next value, simply subtract 8. So what we can write is a sub n will be equal to a sub n minus 1, so the value right before n, minus 8. And we'll say this only applies to n greater than or equal to 2. So if we say, well, let's try to find a sub 5. Let's see if this rule actually works. So if we plug in a 5 for n, down here we would get 5 minus 1. So a sub 4, which we know is negative 5. If we subtract 8, what do we get? Negative 13. So let's verify that. To go from negative 5 to negative 13, we do subtract by 8. So this does follow the rule of subtracting by 8. So those were just 3 examples of how to write recursive formulas for different types of sequences.